Good afternoon, everybody. Welcome back to this second lecture of this day. We have already seen about gas chromatography. We have seen some of the important parts of the chromatographic system, the injector. We have seen the column which is used for the chromatographic separation. And we have also seen something about the stationary phase, isn't it? So now I shall tell you something about the mobile phase, which is used in gas chromatography. Okay, so this mobile phase is supposed to be inert. Okay, so inert in the sense that it should not actually chemically react with the sample components. Okay, and what is happening is there is a distribution or partitioning of the sample components in the stationary and the mobile phase, but there is no chemical interaction as such with the mobile phase. This is a very important point. And therefore, usually we use gases like hydrogen, helium, nitrogen. So these are the kinds of mobile phases which are usually used in the gas chromatographic system. So either we can have a gas cylinder, okay, usually that is more preferred, or sometimes some of the gases can be generated on site, like nitrogen, for example, can be generated on the site, and that can be used for gas chromatographic application. Okay, so when I say generation on the site, it actually means that there is a special instrument which is able to extract nitrogen from the atmosphere. Okay, and that nitrogen can be stored and it can be used for the laboratory purposes. Okay, but essentially what is more important is that all these gases which are used as a mobile phase must be very, very pure. Okay, they should be free from water vapor. They should be free from oxygen, because oxygen is going to deteriorate your samples, because oxygen will itself react with the sample components. It will cause oxidation of the sample, and therefore these contaminants should be preferably removed from the mobile phase, and the mobile phase should be very pure. Okay, so it is actually analytical grade kind of gases that we use for gas chromatographic application. Okay. Then there is also a filter which is used in the gas carrier system, and that filter is there to remove the unwanted gases, or especially water or oxygen or something like that. And the flow of the gas is very important. The gas is actually kept under pressure. Okay, so this is a system which employs high pressure for the chromatographic separation. And the reason why we require that high pressure is that the chromatographic matrix that is used in the column, that matrix is also going to resist the flow of the mobile phase. Okay, and because of that resistance, we have to employ higher pressure so that the mobile phase will pass through that column easily, and the separation will take place. Okay. Then viscosity of the gas is also important, because if the gas becomes more viscous, for example, if the high temperatures are employed, then at high temperatures, the viscosity of the gases will increase. And because of that, the flow rate will reduce. And then if the flow rate reduces, more pressure has to be applied in that system, right? Usually hydrogen is more preferable as a mobile phase, because even at high temperature, the viscosity of hydrogen doesn't increase too much. Okay, it has a low viscosity, and therefore many people prefer hydrogen as a mobile phase gas. Is that clear to everybody?
Yes, sir.
Okay. Then we come to the last point, which is also very important, and that is about the detectors which are used in gas chromatography. We have already seen about what are the types of detectors used in infrared spectroscopy or UV visible spectroscopy, fluorescent spectroscopy, all that we have already seen. But here we have some different types of detectors for gas chromatography as well as for HPLC. Okay, and this is something which I would recommend for you to really go through well properly, because there might be questions that will be asked on this particular topic in the examinations. Okay, so detectors are of two types, as this is the case for every type of analytical instrument that we have studied so far, and that we are also going to study later. Okay, so detectors are of basically two types. One is called as a universal detector, which is sensitive to all the different types of compounds. So it doesn't discriminate between the type of compounds, Okay, it may be organic molecule, inorganic molecule, or anything for that matter, but these are all detected by the universal detectors. And then there are selective detectors which will detect only a particular compound or maybe a group of compounds which are similar. Okay, like sugars, for example. Sugars can be detected, or amino acids. All amino acids can be detected, something like that. Okay, so the selective detectors and universal detectors. This is what you have to remember. Okay, then there are detectors which can reveal information on the retention time or the retention volume. Then there are detectors which can also provide you information about the structure of the molecule. Okay, and then there are detectors which are linked in a series. For example, as I told you earlier, when we studied mass spectroscopy or infrared spectroscopy, I have told you that these instruments can be coupled to the chromatographic systems. Okay, so for example, GC dash mass spectroscopy will actually mean that the mass spectroscopic detector is attached to the gas chromatographic system. And then in the gas chromatography, after we separate the different components, each component is going to the mass spectrometer, and the mass spectrometer will carry out the analysis to find out what is the identity of that particular compound. Is that clear? Or instead of a mass spectroscope, we can also attach an infrared spectroscope for that matter, or NMR spectrometer for that matter. Is that clear to everybody?
Yes, sir.
Yes, sir.
Okay, so this is something that we call as hyphenated techniques. Hyphenated techniques will mean that a particular kind of a sophisticated analytical instrument is attached to the chromatographic system. So on one hand, we get separation of the compounds by chromatography, and on the other hand, we also get the structural analysis of the different components which are present in the sample. Okay, so the first type of detector is called as a thermal conductivity detector. We won't go into too many details of that, but just try to understand that there are filaments in this particular in a particular metal block, which is also called as a catharometer. Okay, these filaments are also called as thermistors. Okay, and they are maintained at a particular temperature. Okay, and then what happens is the carrier gas or the mobile phase gas actually is flushed through the thermistors. Okay, so the thermistors are actually in the path of the mobile phase. Okay, now what happens is one of that filament of the thermistor is flushed with the column outlet. Okay, column outlet means what? The sample will go through that one thermistor, and the other thermistor actually is in contact with the carrier gas which is going through the injector. That is the mobile phase only. Okay, so it is like the reference and the sample that we have seen in the UV visible spectrophotometry. We place there two cuvettes. One has the one has that blank, okay, and the other has the sample. So here one thermistor or one filament is flushed with the carrier gas with the sample, and the other is flushed with the carrier gas without the sample. Okay, and now what happens is because these thermistors are also conducting to the temperature. Okay, because they are kept at a certain high temperature. Okay, now what happens is when the analyte goes through the detector, when the sample molecules are present in that particular mobile phase, then the equilibrium between the thermal conductivity of the gas of the carrier gas and the thermal conductivity of the filament with the sample, that is altered. Okay, and that alteration is detected in the form of the increased or altered resistance. Okay, the filaments will become either more resistant or they will become less resistant to the flow of electric current. Okay, so essentially what we are doing is because of the presence of the sample compound, okay, there is a change in the thermal conductivity of that filament, and because of the change in the thermal conductivity, the electrical charge also is altered. That is, the resistance is altered, and this particular alteration is proportional to the concentration of the analyte. So in other words, more is the concentration of the analyte, more will be the change in the resistance. Is that clear? So on that basis, the change in the resistance will be detected. Okay, it will be shown in the display, and that tells us that a particular sample compound is passing through that column or going to the detector. Okay, that is to say it has come out of the column. When a particular sample component comes out of the column, it will be detected by the detector. Okay, and then as I told you, the the chromatogram is where you will see peaks. Okay, so higher peak will indicate that a high concentration of that analyte, and a lower peak will indicate a less concentration of that analyte, and the position of the peak on the chromatogram will tell you about the retention volume or the retention time. Okay, if you remember in yesterday's lecture, I have told you about retention volume and retention time. And that, as I told you, is a characteristic feature of a particular sample molecule. Okay. So if it is, for example, H2S gas, so H2S gas will have a particular retention time. Okay. If it is, for example, some other gas, maybe oxygen or anything else, then it will have a particular retention time. So retention time tells you about which gas it is or which sample molecule it is. And the height of the peak will tell you what is the concentration of that particular analyte. Is that clear?
Yes, sir.
Okay. Then we move to the other type of detector, which is called as the flame ionization detector. This is a very, very important type of detector, very popular also. Okay. And the reason why it is popular is that it is a universal kind of gas detector for organic compounds. Okay. So different organic compounds can be analyzed using the flame ionization detector. The principle is very simple. Okay. When the gas flows from the column, that is when the mobile phase passes through the column, it is carrying the sample components with it. The sample components will be separated in the column. Okay. And then as you continue to pass the mobile phase one by one, each component will come out of the column. Okay. Now, when each component comes out of the column, it passes through a flame. Okay. There is a flame which is burning at the end of the column, and each sample component, as it comes out one by one, it will pass through the flame. Now, when it passes through the flame, the temperature of the flame is adjusted in such a way that it will cause the combustion, it will cause the ionization of the sample. Okay, burning of the sample component or sample gas, you can say, okay, will cause ionization. And because of ionization, charged particles will be created. Now, these charged particles are allowed to pass between electrodes, okay, two electrodes. Okay, and that is how an electric current will be formed. Okay, electric current is generated. Now that electric current is measured by the, you can say, coulometer. Okay, or if it is a voltmeter, it will measure the voltage which is generated. So whichever way it is, yeah, either it could measure the voltage which is generated, that is potential difference between the electrodes can be detected, or the current which is passing to the electrodes, that can be detected by the detector. Okay, so essentially what is happening, your organic molecule is burnt. Okay, pure, of course it is pure because it is coming out of the column, chromatographic column. So what comes out of the chromatographic column is actually a purified compound. Okay, so one by one the different purified components will come out of the column. They will pass through the flame. In the flame they will get ionized, and because of that electric current will be formed, and that electric current will be measured by the detector. Is that clear? So this whole detector actually involves both, that is the ionization part, the sample compounds get ionized, and then the detector is actually something which measures the electricity or the potential difference. Is that clear? And the intensity of the signal is in the form of peaks on the chromatogram. So again, here the height of the peak will indicate the concentration of the molecule. Okay, and the retention time, that is position on the chromatogram, will tell you about the retention time or the retention volume, and both are characteristic of a particular sample component. Any questions about this? Flame ionization detector. It is also called as FID. Sometimes in the exam, don't be surprised if they ask you a question and in that question they put the short forms FID. Okay, that is because these short forms are also very popular. Okay, FID, TCD, these are popular short forms. So you have to even remember the short forms. Okay, Then there is a third type which is called ECD, that is electron capture detector. Now this kind of a detector is a selective detector. Okay, it is not a universal detector, but it is a selective detector, and it can be used for measurement of analysis of halogen containing atoms. Okay, chlorinated, for example, chlorinated hydrocarbons, for example, or different pesticides which have chlorine. Okay, so or even some compounds which have nitro groups. Okay, halogenated compounds or nitro group containing compounds can be analyzed by using the electron capture detector. Now here what happens is there is a flow of nitrogen gas through the detector. Okay, nitrogen gas flows through the detector, and there is a radioactive source actually. Okay, just this is very interesting. So there is a radioactive material which is placed in that detector, and because of the radioactivity, the nitrogen gas atoms get ionized. Okay, nitrogen gas gets ionized, and when these ions are generated, okay, these ions will interact with the compounds which contain chlorine or bromine or fluorine. Okay, so all halogenated compounds, if they are present in the sample, then the halogens will actually interact with those electrons. And because of the electrons, what we have is a formation of heavy negative electrons. Heavy negative ions are formed. Okay, so electrons are which are generated from the nitrogen gas, they interact with the halogens, and because of the interaction, heavy ions are formed, and these are all negative ions. Okay, these heavy negative ions are slightly heavy. They are heavy, and therefore they are less mobile. And because of that, the less mobility, the electric current which is detected by the detector, okay, it is detecting the electric current, but because of the presence of heavy negative ions, the intensity of that electric current is reduced. And when the electric current is reduced, it is a signal. Okay, that signal is indicative of the presence of halogenated atoms in the sample, or halogens in the sample. Is that clear?
Yes, sir.
Okay, so that was about electron capture detector. Then there is one more detector which is called PID, that is photo ionization detector, and this is more useful for hydrocarbons and sulfur and phosphorus containing molecules. So in a way, these are also selective kind of detectors. Okay, so here what happens is we have UV light. Okay, UV light falls on the sample ions, and because of that strong UV light, the sample ions get ionized. Okay, sample ions get ionized. And because of the ionization, electric current is generated, and that electric current is detected by electrometer or colorimeter. Is that clear? Or amperometer, you can call it also as an amperometer, which detects the current. Okay, so essentially what is happening is UV light is falling on the sample, that is creating ionization of the sample molecules, and that ionization leads to an electric current, and that electric current is detected. Okay, so that was the fourth type of detector, photo ionization detector. And then we have the very important types of detectors, which are called the detectors useful for identification of a molecule. For example, as I told you some time back, mass spectrometry detector is linked to the gas chromatographic system, and this mass spectrometer will then tell you about the identity of the compound, isn't it? So we have already seen what is a mass spectrometer, how it works, how it is used, how it is, what are the applications of mass spectrometer. Okay, so the sample molecules which are purified in the column, one by one they come to the mass spectrometer, and mass spectrometer will be able to identify what is the type of the molecule. Similarly, we have atomic emission detector. So this is something which is related to the atomic absorption spectrophotometer. I have not told you anything about that instrument, and I'm planning to share you my recorded video for that. Okay, so maybe today I'm going to share about radioactivity, unit 5 radioactivity, and maybe by tomorrow I'll be able to send you this link for atomic absorption spectrophotometry or atomic emission spectrophotometry, as well as atomic force microscopy. Okay, so there you will probably understand that an atomic absorption spectrophotometer or atomic emission spectrophotometer is useful for the identification of metals, okay, heavy metals especially. So if there are heavy metals present in your sample, then they will be detected by this kind of detector. Okay, metal containing compounds can be detected by using this detector. Is it okay? We can also link a FTIR instrument or a Raman spectrometer also. Okay, we can put an NMR as a detector. Okay, so whatever things we have learned in the analytical part in spectroscopy, that those instruments can be attached to the gas chromatographic system or HPLC system, and the sample molecules can be actually identified. Okay. Yeah, so I think that was all for this lecture. And this particular topic on gas chromatography is over. And in the next lecture, I will tell you about the HPLC system. Again, I'll need at least, I think, 3 lectures for that. So tomorrow we have research methodology lecture at 10:30. Okay, after that lecture in the afternoon, maybe just like today, what we are having this lecture. So just like today, we will have a lecture tomorrow at maybe 3 o'clock. Okay. And in that lecture, I will tell you about HPLC. So tomorrow and day after tomorrow, if I get 2 lectures consecutively, then maybe at least 50% of that particular topic will be completed. Is that okay? Any questions?
No, sir.
Okay, boys, any question? Akash?
No, sir.
Akash, Bhimbhushan, Satish?
No, sir.
Okay, Satish, today I'm going to send you the link for my videos. So please ensure that everybody gets that link. Okay, you have another group, isn't it? WhatsApp group.
Yes, sir.
So in that group, you can please share it immediately today so that everybody will be able to read about radio, to listen to that video, see that video. And then what I'm planning is, see, on Sunday, I'm having, I'll organize a test on unit number 2. Okay, that is spectroscopy. Is that okay for everybody? Sunday?
Yes, sir.
Sunday evening, is
Yes,
it
sir.
okay? So that you get complete
sir.
1 day for preparation. From morning, you can start your preparation. And by evening, maybe what time shall I have that test? What is suitable for you? 8 o'clock in the evening. Is it okay? So you get complete day for preparation. चालेल का रात्री 8 वाजता?
हो सर.
हा?
Yes, sir.
Okay, sir.
आणि फक्त एक मी कोणाला तरी रिक्वेस्ट करतो, मे बी कोणाला सांगू मी, दिव्या कॅन यू हिअर मी?
Yes, sir.
Divya, by 7:30 you have to remind me about that test. Can you
Yes,
remind
sir.
me?
Yes, sure, sir.
आणि जर दिव्याच्या पण लक्षात नाही राहिलं तर दुसरं कोणी पण मला ग्रुपवर जरी टाकलं तरी चालणार आहे. You can just remind me on the group that, sir, we have a test at 8 o'clock in the evening. Okay. Being a Sunday, I might be involved with my family. So I do not know if I forget this, it will be a loss for all of us, isn't it? So please remind me, Divya and all others. Others can also remind me. Okay. 8 o'clock सगळ्यांना ठीक आहे ना रात्री? म्हणजे फार टेन्शन नाही, तुम्हाला काय दिवसभराचे जे काम करायचे ते काम करा, तुम्ही अभ्यास करा, सगळं करा. आणि रात्री 8 ते 9 किंवा 8 ते 8:30, इवन हाफ एन आवर इज इनफ फॉर दॅट टेस्ट. ऑब्जेक्टिव्ह टेस्ट किती पाहिजे तुम्हाला? प्रश्न 10 की 20 पाहिजे? 10 questions I'll ask you. Okay. So 30 minutes is more than enough.
Okay.
By 8:30 you will be free. Okay. आणि मग रेडिओ ऍक्टिव्हिटीचा मी जे देणार आहे सतीशकडे, आय एम गिव्हिंग लिंक्स फॉर द व्हिडिओज to Satish today itself, and that test we will have on Tuesday or Wednesday. Can we have it? Wednesday, चालेल? तुमचं दुसरं काही टेस्ट असेल तर सांगा मला.
Sir, on Saturday we have
Saturday, which after this Sunday?
test of the
Date काय
no
आहे?
no no the Saturday.
This Saturday.
No,
Okay.
The Saturday.
हो ना.
So we can take on Wednesday, sir. Tuesday,
हा,
Wednesday.
कमिंग वेनसडे. म्हणजे कसं की ह्या सॅटर्डेला टेस्ट होईल, संडेला मी तुम्हाला पूर्ण दिवस देतोय. होल डे यू हॅव फॉर द प्रिपरेशन ऑफ द टेस्ट. संडे इव्हनिंग वी हॅव द टेस्ट ऑन युनिट नंबर 2. ओके. आणि युनिट नंबर 4 ची टेस्ट म्हणजे रेडिओ ऍक्टिव्हिटी, दॅट इज युनिट नंबर 5 आय थिंक. सो दॅट टेस्ट आय विल कीप ऑन वेनसडे. ओके. वेनसडे म्हणजे डेट काय सांगू का तुम्हाला? आय थिंक इट इज 9th February. इज इट ओके? 9th February. आज आहे 3 तारीख. ओके. सो यू हॅव इनफ टाइम. आणि माझे व्हिडिओज असल्यामुळे यू कॅन लिसन टू द व्हिडिओज अगेन अँड अगेन. नो, with that same link you can again and again see the video, try to understand it. Okay, yes or no?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
तर मग मी लिंक आजच देऊन टाकतो सतीश कडे, and you will get it.
Okay.
Okay, then bye everybody. Tomorrow we have
Thank you.
lecture on research methodology at 10:30 a.m. Okay, and in the afternoon at 3 o'clock, maybe I'll declare it tomorrow itself. After tomorrow I'll tell you on the group that we have a lecture at 3 p.m. Okay, so then I
Yes,
can
sir.
complete HPLC also maybe in 3 days time. Okay, bye.
Thank you, sir.
Okay, thank you.
Thank you.
Yes.